Hey, let's talk about hydroelectric power or hydroelectricity. So, hydroelectric power is basically a renewable energy source, which is really cool, right? So, the idea is we're going to take advantage of the flow of water as it travels downhill in a river, usually. And we're basically going to use it to turn a turbine, which will then turn an electrical generator and make electricity. And so, the beautiful thing about this is we're doing this without burning fossil fuels. We're just taking advantage of the flow of water from high ground to low ground. That's what we mean by that. And it's worth noting that we could also talk of hydropower in terms of tidal power, like trapping water behind, as the tide comes in and trap the water. There's some talk of that, but we're really not going to get much into that in this course. Okay, so College Board would like you to understand the energy implications here, like the nuts and bolts of energy transfers that happen in a dam. So here's the idea: the water behind the dam has gravitational potential energy. Where did it get it from? Well, the sun lifted it out of the ocean, picked it up, and deposited here. So it went from having a small amount of potential energy to a large amount of potential energy. In a sense, they're solar powered. Okay. Now, what happens then is this: as the water flows through a dam, it goes from high ground to low ground. So down here, that water has less potential energy than it had here. Now you can't create or destroy energy, first law of thermodynamics. So you have to transfer that energy into other forms or other objects. So what happens is, as it moves downhill and loses potential energy, it gains kinetic energy, the energy of motion. Then it hits this turbine. Now, this turbine, remember, is just basically like a paddle wheel, a propeller. Okay. And so what happens then is the water is going to be slowed down by its interaction with that. So it's going to lose kinetic energy. Well, where's the energy goes? Well, it goes into the motion of the turbine. Not really, the turbine just has some of that kinetic energy, but we're going to call it mechanical energy. But really, it's just motion, it's just kinetic energy of the turbine. Now, that turbine then is going to spin an axle that will then turn the coils of wires inside a magnetic field inside the generator, and then that's gonna cause that mechanical energy then to be transformed into electrical energy. So basically, that's what's happening inside there. We're basically turning gravitational potential energy into kinetic, into mechanical, into electrical, and sending out to people's houses. That's the main reason why we build dams. Now, it's not the only reason we build dams, but it's the main reason we build dams is to get access to, you know, electricity. Basically, it's not really free because you had to build a dam, but it's nice because it is renewable. Okay, so let's talk about some of the advantages of hydroelectric power. The biggest one being it is a renewable energy source, meaning it regenerates itself. It never goes away. It's not like coal, oil, natural gas, nuclear. Once you use them, you lose them. In this case, it's always going to be there as long as the sun shines. The sun, which it's going to do for another 5 billion years, it's always going to lift water out of the ocean and drop it as precipitation in the mountains, which will then want to flow downhill to the ocean. And as long as we build a dam, hey, we've got it. Okay, so it's never going to go away. That's one really good thing about it. That's probably the best thing about it. Another thing that's obviously really important is this: it does not involve the burning of fossil fuels. The burning of fossil fuels, no matter what we do, produces carbon dioxide in the atmosphere. Carbon dioxide in the atmosphere leads to global warming and climate change. So it's good to have some source of energy that doesn't do that. And dams are one of the few widely used forms of electrical generation that do not contribute to climate change. Now, keep in mind, neither does nuclear, but nuclear is not renewable, at least the way we currently use it. Another advantage, and we really need to dial in on this. In future lessons, we're going to talk about wind and solar. And here's a problem with wind and solar. You know, these propellers spin these turbines when the wind is blowing, but sometimes the wind's not blowing, so they're not generating electricity. And then the wind blows a lot, so we're generating a lot of electricity. So it's highly variable. The sun is shining, we're making lots of electricity. Now it gets cloudy, now we're making less. Now it's night, we're not making any. So the problem with wind and solar, which are also renewable, is they're highly variable. They're constantly changing. The nice thing about hydro is we know how much we're going to get. And that's really important with an electrical system. You can't have huge changes in the amount of energy in your grid. You need to have it pretty consistent. And that's what's nice about hydroelectric is that you're able to make sure you know exactly how much you're going to get when you want it. There are some other important advantages. I'm just going to put them all on one page here, but you need to process these individually because they're all important ideas here. Okay, so what are some of the other advantages other than electricity that we get out of the dam? Okay, well, we basically have a large reservoir of water. And so instead of this water is flowing to the sea, now we've got it stored, right? So we can use it for drinking water. Like Here in the Seoul area, there's a dam on the Han River, and that's where we get our water from. Without it, we wouldn't have water. Okay. Uh, it also prevents you from having to pump water out of aquifers. It helps recharge aquifers, in fact. It also provides water for irrigation of crops. That's a big one. So in a lot of areas, like in like in the Nile area, in the Western United States, in fairly arid areas, that you couldn't farm without water, and so the water is coming from these reservoirs. Another thing is this: it prevents downstream flooding. So, because I can control the flow of water, when there's a large rain event, rather than immediately causing flooding, I can basically portion that water out in a way where I can keep it from getting too high and flooding downtown streams. In fact, the biggest dam in the world, the Three Gorges Dam in China, it wasn't built to make electricity. It does make electricity, but that's not what it was built for. It was built in order to control flooding on the Yangtze River. And the other thing is it provides recreational activities like fishing, boating, water skiing. It makes all this waterfront property that people want to own, so it increased the value of the land that more than it had before. So there are a lot of these other advantages that have nothing to do with electrical generation. Let's talk about some of the disadvantages, and there are a lot of them. Okay, so let's start with this. Dams are temporary, and the reason they're temporary is as soon as you build this dam, what's going to happen? The water here is not moving. Normally, when water's flowing, it carries sand, silt, and clay with it, right? But now what happens is I have a lake now. Well, water doesn't flow in the lake. So what happens is all that sediment just falls out. So what happens is as soon as you build that dam, you start getting this uh, plume of, like, basically a delta starts to form here, right? And so more and more of the sand and silt starts to fill this up to the point that the dam's not going to operate anymore, and the lake behind it is now just this big reservoir of silt. So the sedimentation of dams, the siltation of dams, is a huge problem. All right, because it means that your dam's not going to last very long. And you might last 40, 50 years, but if the idea is this was last 5 billion years, well, it's not going to. The dam might, right, but the it's not going to do any good because it's filled with sediment instead of water. Now let's talk about that sediment. That sediment was, in a normal situation, it would flow downstream and it would be deposited in the floodplains of the river, where it'd be useful for agriculture and riparian ecosystems. And also at the mouths of rivers, we have these delta environments, are really important wetland environments, super, super important for many different aquatic species, all right? Fish species, migrating waterfowl, and so on. And what happens is you start building dams along the river, all these locations here, show you all the different places where these dams have been built. Now you don't get as much water flowing. This is in India. Water is no longer flowing into the Bay of Bengal, so you're getting all this erosion of this delta area and erosion of the riverbanks downstream from there. Another problem is just the nature of building a dam. You're taking what was a river and now you're making a lake, so that everybody who lived here and all the animals that lived here are now, everything's changed, right? So like this riparian or river system ecosystem is now a lake, is a totally different ecosystem. And all the people who lived along the shores here, like you could have cities here, you got to move them. There's this lake. I used to live in South Carolina. There's a lake at the bottom of the lake. Scuba divers go down. There's whole towns. People scuba dive through these weird underwater towns. They built a dam. The towns got flooded. Those people had to move. So many people got displaced and they built the Three Gorges Dam. Millions of people. Another real major problem that you should know about with hydroelectric power is that it disrupts the migration of many fish species. So a lot of salmonid fish species, trout, salmon, sturgeon, they have a tendency to go upstream to lay their eggs and then come back downstream as adults. Well, if you build a dam, they can't do that. So what do you do? Well, a common mitigation is to build what's called fish ladders. This works for salmon because they can jump. So you make it so they can jump short. They obviously can't jump over a 200-meter high dam, right? So you just make these little jumps for them, and eventually make it to the top. Well, a lot of them don't do it, and a lot of times they just truck them. They collect them at the bottom in big nets. They put them in a truck. They drive them over the dam, let them go. But still, it's very disruptive. Plus, too, a lot of times their migrational indicators are the flow of water, and behind the dam there is no flow of water. And another one is climate change, right? So this is becoming really, really evident in the American West right now. Uh, in California, along the Colorado River dam systems. You look here, you can see that this used to be a lake, a very large lake. This is Lake Shasta. And now, basically, it doesn't look like much different than a river. Why? Because it all dried up. climate change is causing a disruption of the hydrologic cycle. It's not raining there anymore, and since it's not raining there anymore, the reservoir is not filling up with water anymore. So now it's just draining away. So now you just got this weird dead system here that sometimes fills up, but then you can't get hydroelectric power because there's no potential energy here. So definitely climate change is making a lot of dams no longer able to fulfill the role for which they were built. All right, let's look at a couple specific ones. College Board, like I would say about there's two you should really know about for sure. Okay, so the Three Gorges Dam project in China is the largest dam ever built in the world, and it really does a good job of showing the benefits and the problems with dams. Okay, so let's talk about the benefits of the Three Gorges Dam. So it provides as much energy as 30 coal-fired power plants, and in China that's important because they got a problem with their air quality, right? So that's wonderful, right? It also, like I said, it was built. Chairman Mao was the one who came up with the idea of building it because of the flooding problem on the Yangtze River. So by building this, you definitely prevent flooding in the downstream areas. You've got this huge reservoir of water, so there's lots of agriculture. It also makes the Yangtze navigable, so you can have boats travel up it. There's cruise ships that go along it just as for fun, but it also is for commercial traffic. Uh, so those are some wonderful advantages it provides. But here's some problems. When they build it, over 1 million people had to be displaced. Cultural relics got lost. Some of them got moved. Some of them just got submerged. Uh, Downstream, the erosion of the riverbanks, the erosion of the Yangtze River Delta, uh, a loss of habitat for a lot of endemic species, such as Chinese river dolphin, different fish species. Uh, Weirdly, believe it or not, it changed the rate at which the world spins in a measurable way. Just like when a ballerina puts her hands out, putting all that water up high changed the spin of the world, which is pretty impressive. Okay, but also that weight causes earthquakes and landslides. Also, sewage that people used to just put their sewage in the river, which maybe isn't a great thing, but at least it would carry it away. But now it builds up in the lake and it's causing health problems. Like there's bacteria in it that are causing pathogens to get into people and animals, and also too that water that's not flowing now is a place where different insects can breed, some of which are disease vectors. So it's so frustrating, right? You're trying to do a good thing, and there's all these problems too. That's the nature of environmental science, but we have to look at it with open eyes. Now, let's talk about dam removal. So, this is kind of an interesting thing. We've moved into a new phase. Generally speaking, most environmental scientists are anti dams. They just say it just causes too much disruption of ecosystems for the benefit that you're getting out of the dam. So in Washington State, where I come from, there's a very, very famous example of this where it's the first time major dams were removed. So these two dams were built along the Elwha River back in the early 1900s in order to generate electricity for sawmills. Now, the logging industry dried up in the area, but these dams are still sitting there. And now the Elwha River system above the dam is this vast, beautiful, pristine, like virgin forest, never cut down trees, thousands of year old trees. This is wonderful ecosystem with no salmon in it. It used to have these huge salmon, 150-pound king salmon in there, Chinook salmon, but now they can't get past the dam, right? Uh, and so people say, well, let's just try this. Let's try getting rid of the dam. So in 2011, they took these down in order to let the main thing was to let the salmon come back up the river. And it's just this big experiment. Now let's just see what happens. So like all the silt that had built up behind those dams for 100 years, it's now moving to the sea. So instead of eroding the delta, we're building a delta. Uh, Salmon are coming up and spawning in these rivers again. So it's kind of new. So it's only been last 10 years or so, but it's a very exciting area of research because this may be a model for what people are going to do with a lot of the world's dams. So as much as it seems like yay renewable energy from dams, a couple of problems. One is well, we'll talk about it in a second. Okay, first I want to show you a picture here. So look, here it is when this is what it looked like, and then look how it grew over time. And I've been there. I've been surfing out here. I've been just hiking out here. It's remarkable how it changed after they took that out. Okay, so let's just talk about the pros and cons, and we'll be done here. So the pros, okay, it's renewable. Water is always going to flow as long as the sun shines. It doesn't produce carbon dioxide, so it's not contributing to global warming. It's consistent and constant, so it's not dependent on the weather or how fast the wind is blowing. It allows you to control flooding. It provides water for irrigation. Man, those are all great advantages of a dam, but causes huge disruption to ecosystems, especially to migratory fish species. It causes erosion of the downstream, rivers and deltas, which again impacts a lot of animal species. The silt from the reservoir tends to fill up the dam, making it really a temporary power source. And here's another one I haven't talked about yet, but this is important. So as we start looking for like what are we going to do to solve our energy problem to get ourselves away from fossil fuels, a lot of people say let's build more dams. Problem: pretty much every place in the world where a dam would provide significant amounts of electricity, that dam has already been built. It already occurred to people to do it, right? You just can't build them everywhere. You got to have this narrow gorge where it can build up. You can't do it in a wide open area. And so it turns out really we've dammed every dammable river there is of any significance. So there's no future in hydroelectric in that sense. Thanks for watching.